Good day, viewers. You are welcome to Elem online class. Today, we want to do the final revision on elementary maths 2, that is calculus. So we want to do the final revision on calculus. And of course, this will be divided into both integral and differential calculus. So we'll be talking about differentiation and integration. So the first concept that we are going to talk about today, because the nature of the question will be multiple choice, that is objective questions. So we are going to have, it will require short steps to be able to solve the problem. Then we are going to pick the right options. So I'll be starting with the first concept, which is limit of a function. I'm going to give some questions on limit of a function before we go to differentiation. Then after differentiation, we talk about types of differentiation, give simple example. Then we now go to integration. Okay. So the first thing that we're going to talk about is example 1. Let's start with the first one. Is when we have to find the limit of a function. For instance, you can be asked to evaluate the limit as x tends to 5, 3. So let's look at this problem. If you have to evaluate this limit, what are we expected to do here? It's very simple. Don't bother yourself. When you see limit as x tends to 5, it simply means that by the time you substitute, this simply means that x tends to 5. That is, we just assume x to be equal to 5, because x tends to 5 simply means as x approaches 5, either from left or right. So this is what we're going to just write. This will go to 3x minus 7. When x approaches 5, that will be 3 into bracket 5 minus 7. What is 3 times 5? 15 minus 7, and that will be 8. So without doing any working, you can go ahead and get your answer. Without doing any working, just look at the question and get your answer. Let's take another example. Under limit of a function, if you have evaluate, you can have something like this. Evaluate limit. We can have something like this. Limit as x, where we have as x tends to 2. If you have x minus 2, x squared minus 4. So let's look at this form of a fraction. So what do we do when we have the problem in form of a fraction? What do we do? If you have the problem in terms of a fraction, it's also simple and straightforward. It's simple and straightforward. This is what you're going to do. Just say limit as x tends to 2, x all over 2 all over x squared minus 4. Look at that denominator very well. In case of this denominator now, it is called difference of 2 squared. X squared minus 4. This is the same as x squared minus 2 squared. Square, this is square, this is square. The operation here is minus. So this can be expressed as x minus 2 into bracket x plus 2. That's what we're going to get. So I'm going to express this now. X squared minus 4, the denominator, I will now say this same thing as limit as x tends to 2. I will have x minus 2 all over x minus 2 into bracket x plus 2. This is how we express this. X minus 2 can cancel x minus 2. At the end of the day, you have limit as x tends to 2, 1 over x plus 2. And of course, by the time you substitute x equal to 2, limit will not be there again. Just say 1 over 2 plus 2. And that will be 1 over 4. And that will be the answer. So we will be required to pick the right answer. So if you want to pick the right answer, that is what is expected. So that's what is expected. Just do what you have on the board, then you get it. Or this same example, if you don't want to bother yourself, since we are still going to do differentiation, then this is what you do. If you don't want to do it this way, if you have limit of a function in form of a fraction, numerator and denominator, you use what is called the L'Hopital rule. L'Hopital rule. What's the meaning of L'Hopital rule? L'Hopital rule simply means that you differentiate the numerator and the denominator before you substitute. Okay? So if I differentiate the numerator here, if I differentiate what I have here, I'm going to get 1 all over. If I differentiate the denominator, this will be 2x limit. That is, we have limit as x tends to 2. 1 over 2x. So this is capital rule. Then just go ahead and substitute 1 over 2 into bracket 2. Then that will be 1 over 4. So whenever you have limits as x tends to a particular value, not infinity, just you can go ahead and apply capital rule. Just differentiate the numerator and the denominator and get your answer. Then let's take another example. See example 3 under limits. You can also have question in this one. Please, I want us to note the difference. Example 3, you can be asked to evaluate. In the first two example, x tends to a particular value. But in this case now, whenever x tends to infinity, what is the implication? That is, when you are asked to evaluate, you are asked to evaluate limit as x tends to this symbol undefined 4x minus 3 all over 2x plus 2. Look at this problem now. If you have x, look at this problem. In this case now, x tends to infinity. If you have something like this now, you are going to look for the highest degree. You look for the highest degree of x. In this case, it's x raised by 1. Okay, it's possible. It's possible to have x squared. What you are going to do is that you now divide all the entity here, both the numerator and denominator, by the highest degree of x. So let me say this is x squared. Then what am I going to get here? I will say limit as x tends to infinity, undefined. So the highest degree of x is 2 here. I will say 4 all over 4x all over x squared minus 3 all over x squared all over the denominator 2x squared all over x squared plus 2 all over x squared. So what is the implication? This will cancel this. At the end of the day, this will cancel this. At the end of the day, what you are going to get is that all the values that have x, all the values that have x at the denominator will tend to 0, will be equal to 0. They will vanish. And once they vanish, you can get your answer. They will vanish. So in this case now, what I'm trying to say in essence is that here I'm going to have 4 all over x, it will be 0, minus 3 all over x squared will be 0, all over this will be 2 plus 0. At the end of the day, you have 0 over 2. The answer will be 0. Okay? That answer will be 0. That is how to go about that. So when you have the limit as x tends to infinity, this is what you are expected to do. So look for the highest degree of x. The highest degree of x here, in this case, is x squared. Then you use it to divide. But what if, let's say example 4. Example 4, we now have something of this nature. So maybe in this case now, the highest degree of x, we have something, let's say example 4. Let me rewrite this question. Where we have 7x squared minus 2x plus 1 all over, I have 3x squared plus 8x plus 5 as x tends to infinity. So what do we do here? What do we do here? In this case now, this will be the first example under limit of the function. Then go to differentiation. In this case now, it's the same limit as x tends to infinity. The highest degree of x here is squared. So we say 7x squared all over x squared. You divide through by the highest degree of x, 2x all over x squared plus 1 all over x squared. That's for the numerator. You come to the denominator, 3x squared all over x squared plus 8x all over x squared plus 5 all over x squared. So in this case now, x squared will cancel x squared here, x squared will cancel x squared here. But you realize that x will take care of 1, x will take care of 1x here. Everyone that has x, either x or x squared at the denominator, everything will become 0. All this one will become 0. At the end of the day, what do you have left? 7 all over 3. And that will be the limit of that function. That will be the limit of that function. So you can have question in that form. We can have question in that form. Just note that it's the function. For example, under the limit of the function, you can have any. You can the question, likely question that you can get under the limit of the function cannot exceed what we have actually discussed. So we go to example 5. Now I want to introduce differentiation. So we start with the general form of differentiating a function. Okay, I want to introduce differentiation. So under differentiation, what is the general form of differentiating? If y is a function of x, then the differentiation of y with respect to x simply means dy dx. That will be f prime of x. That is, we are going to differentiate the function. And this function could be any function. As we are going to see example now. We have so many functions. You can check my video on special functions. We can have polynomial function, transcendent function. We have so many functions. So many functions. We can have exponential function, logarithm function, so many functions. So depending on the nature of the function, will determine what we are going to do. So when we have polynomial function, then I want to start now. If y is equal to x raised power n, then what is the derivative? dy dx, the differentiation will be this n here must be positive whole number. Will come down if you want to differentiate x into n minus 1. That is, whenever you are to differentiate polynomial function, look at the power. You bring down the power, now subtract 1 from the power, as we have it on the board. So you can be asked to differentiate with respect to x. So you can have so many questions under differentiation. For instance, if the question says differentiate, you can be asked to differentiate y is equal to x squared x cubed plus 4x squared minus 8. This is the question. We have to differentiate what you have on the board. How do you differentiate this? Just say dy dx is equal to, this 3 will come down. You subtract 1 from 3. You have 3 x raised power 3 minus 1. Then plus, this 2 will come down to come and multiply 4. You have 2 times 4. X raised power 2 minus 1 minus, when you have a constant, the differentiation of a constant is 0. So please note, the differentiation of a constant is 0. Because what you have here is x raised power 0. If 0 should come down, it will multiply, it will vanish everything. So the differentiation of a constant is 0. No matter yourself, when you see a constant, the differentiation is 0. So here I'm going to have 3x squared plus 8x, and that will be the answer. So this is how to differentiate. You can have, if you have this type of question, just go ahead and differentiate. This is how to differentiate. Just differentiate directly, then you get your answer. Okay? So let's take another example, say example 6. You can also be asked, you can have so many funny questions. You can also be asked to differentiate y is equal to 4. If y is equal to 4, the question now says find dy dx. We know 4 is a constant. And whenever you differentiate the constant, you are going to get 0. So in this case now, it's very simple and straightforward. Just say dy dx is equal to 0. That's what you get. Because when you differentiate the constant, the value that you're going to get is 0. Okay? So the value that you're going to get will be 0. So we take another example. So this is the derivative of the differentiation of a polynomial. What if you are given y? If you are given y to be equal to sine x, sine 2x, and you have to find dy dx, what are you going to do here? In this case now, this is example that trigonometric function, trig function. So if y is equal to sine x, sine 2x, then what is dy dx? Dy dx, I will use the method now. So in this case now, this is 2x. The derivative of sine is cos. Cos is minus sine. Tan is sec square x. So you can check my videos on that. But if you have this, you can say let u equal to 2x. So that y will not be equal to, no, if u is equal to 2x, you say du ds will be equal to 2. We know that. So that y will not be equal to sine u. If y is sine u, dy du will now be what? Cos u. Then finally, we have to find dy ds. What is dy ds? It's function of a function. Dy ds will now be du dx multiplied by dy du. So what is du ds? Du ds is 2. Say 2 multiplied by dy du is cos u. Cos u. At the end of the day, we have it to be 2 cos u. But you are given the question in the form of x, not u. So we now recall that u is equal to 2x. At the end of the day, you have it to be 2 cos 2x. That's what you are going to get. So if you are given any question, other trigonometric functions, you don't need to bother yourself. Okay? You don't need to bother yourself. What you are expected to do is that, look at what you have here. Just differentiate what you are given here. Once you differentiate what, in this case, that is 2x. If you differentiate, that will be 2. Then just find the derivative of sine. Just say 2. When you differentiate sine, it's cos 2x. That's the answer. Okay? So you don't need to follow the process. If you are in multiple choice question, you don't need to follow the process. So you don't need to follow the process. Oh, I see your comment. No, it's not my handwriting. It is the network. Okay? So let's see another one. Example 8. Let's see another example. In this case now, in this case now, in this case now, let's have something like y. Let's have something like y to be equal to tan 7x. The question now says find by dx. So you have to note the derivative of this trigonometric function. When we differentiate tan, if we differentiate tan, we are going to get sec square. Whenever we differentiate tan, we are going to get sec square. Okay? If we differentiate tan, we are going to get sec square x. That is what we are going to get. So please let's take note. Let's take note. When we differentiate tan, we are going to get sec square x. So in this case now we have to find tan. We have to find tan 7x. So what do we do? How do we find tan 7x? So we just go. This is what you do. Solution. If it's a multiple choice question, you don't need to write in any formula. Just say dy dx will not be equal to. Look at what we have here. This is 7x, right? If you differentiate 7x, what are you going to get? You get 7. Okay? You are going to get 7. Just write 7 here. Then what is the derivative? Differentiation of tan. Differentiation of tan is sec square. So we are going to have it to be sec square 7x. And that's the answer. That's the answer. Instead of saying let u is equal to 7x, so that you know why it's equal to 2. Just shorten everything. You can shorten the process. You shorten the process. At the end of the day, this is what you are going to get. You don't need to stress yourself. So you don't need to stress yourself. So if that's when you have, then another question is when we have exponential function. Example 9. Okay? If the question says differentiate e raised power 3x. This is an exponential function. Okay? So what do we do if we have exponential function? Of course, if y is equal to e raised power x, then dy dx does not change. Dy dx will be e raised power x. That's just it. You can check my videos on exponential function. But in this case now, the coefficient of x is not 1, it's 3. So what do we do? It's the same thing. I'll go through the process, then I'll tell you how to go about it without writing anything. If y is equal to e raised power 3x, you can say let u, function of function, let u is equal to 3x, so that the u dx will be equal to 3. At the end of the day, y will be equal to e raised power u, then dy du will be equal to e raised power u. It does not change. Okay? Finally, dy dx that we are looking for will be du dx multiplied by dy du. So du dx is what? Du dx is 3 multiplied by du dy, that will be e raised power u. At the end of the day, we have 3e. What is u? 3s. That will be the answer. Okay? But for multiple choice question, you don't need to go through all this process. What is expected is that if you are given this question, if you are given the question as you have it on the board, if you are given this question, just differentiate what you have at the exponential. That is 3x. When you differentiate 3x, you are going to get 3. Then you write what you have. Let's say 3e 3s. So if this is derivative function, differentiation of exponential function, once you differentiate the power, use it to multiply. But if it is integration, if you say integrate e raised by 3x, differentiate the coefficient, use it to divide. That's just the logic when you have exponential function. If you are given exponential function, differentiate the power, use it to multiply. That is the logic under differentiation. But if it is integration, if the person says integrate e raised by 3x as you have it on the board, differentiate that power, use it to divide. So when you have multiple choice question, you don't need to bother yourself. You don't need to stress yourself. Just look at the question and get and pick the right option. Okay? That is what you are supposed to do. So instead of going through all this process, you don't need to go through the process. If you are given this type of question, just look at it and write out your answer. Let's take another example on the exponential function. Let's say example 10. When you have y to be equal to e raised power cos x, you can have this type of question. It's still exponential function. So you have to understand all these functions before we do any calculation. In this case now, solution, you have to find dy dx. Dy dx will just be, when you differentiate cos, it is minus sign. But when you differentiate sine, it is cos. Okay? When you differentiate cos, it is minus sign. So if I differentiate cos x, I'm going to get minus sine x exponential cos x. That's the answer. Okay? That's the answer. But if the question were to be integrate y is equal to e raised by e cos x, when you differentiate that cos, you get minus sine x, you just use it to divide. When you differentiate, you multiply exponential function. When you divide, differentiate the power, use it to multiply. And that is what you are going to get. So we have so many functions. I've been able to consider trigonometric function, polynomial function. We can even have this exponential function. This exponential function now. We have so many types of functions. But since it's multiple choice question, we can have question in this form. So that is that about that. Okay. Another thing that we can have is when you have logarithm function that is in log ex. But before we go into that, I want us to consider another example. Example 11. Example 11, where we have question in form of product. The question says differentiate y is equal to 3x into bracket x plus 1. Find dy dx. You know, this is the product of two functions. It's the product of two functions. Or let's say here is e raised by x. So this is the product of two functions. So in this type of question, you have to apply product rule. You have to apply product rule in this type of question. You have to apply product rule. Can you show us how to double derivative? Okay, we are going to tell you, when we get to add the derivative, I'm going to tell you. So in this case now, we have y to be equal to e raised by x into bracket x plus 1. So it's the product of two functions. This polynomial function, this exponential function. You call the first one u, you call the second one v. It's very simple and straightforward. The derivative dy dx will just be u dv dx plus v du dx. What do I mean by that? If I find the derivative of this function, you pick this first one, e raised by x, you differentiate the second one. When you differentiate constant 0, differentiate x, that will be 1. Plus, you now come back and pick this one, x plus 1. You now differentiate this one. When you differentiate e raised by x, it's same thing as e raised by x. That's about exponential function. At the end of the day, you're going to have e raised by x plus this multiplied by this, x e raised by x plus e raised by x. So at the end of the day, e raised by x plus e raised by, you have 2 e raised by x plus x e raised by x. And of course, you can write it in this one, say 2 plus x into bracket e raised by x. Okay? That's the answer. Okay? It's very simple. When we have a product rule, it's very simple. Okay? That's the type about product rule. So, you can have question in this form. You can have question in any form. You can have this type of question. Let's take another example, example 12. If you now have question in form of fraction, that is quotient rule. That is, if the question says differentiate 1 all over x plus 1. You can have this type of question. Well, the question says 2x all over x plus 1. You know, this one is in form of fraction now. We are going to think about quotient rule. We are going to use quotient rule to solve this type of problem. Okay? You think about quotient rule to solve this type of problem. So we are going to use quotient rule to solve this type of problem. Then how do we use quotient rule? If y, you call the first one, this is y is equal to 2x all over x plus 1. Call the denominator u, the denominator v. So the formula dy dx simply means v squared, that will be the denominator. You square the denominator, then the denominator will now be v du dx v dx. That's what you are going to get. Okay? That's what you are going to just substitute. What is v? The denominator, x plus 1. Multiply by du dx. The denominator, if you differentiate 2x, that's u. U is 2x. Du dx will now be 2 minus what is u? 2x. Multiply by, if you differentiate v is equal to u, x plus 1, that will be 1 all over x plus 1 all squared, v squared. If you open up the numerator, what are you going to get? Here we are going to have 2x plus 2 minus 2x all over x plus 1 all squared. This will cancel this. At the end of the day, your answer will be 2 all over x plus 1 all squared. So if you have question in form of fraction, we are going to apply quotient rule. Quotient rule, that's what we are going to apply. Okay? We are going to apply quotient rule. So most of this, what we are just doing the revision, we have the notes already. So we are just trying to do revision here. So that is another area or angle that we can have question. Then there's what called implicit differentiation. Question can also come under implicit differentiation. For instance, if you are to differentiate, the question says, given, we can have something like of this nature. When the question says, given, example 13, where we have given that x squared plus y squared is equal to 4. The question now says, find dy dx. So in this case now, we have both the numerator and the denominator together. We have everything together. Okay? We have everything together. It's not explicit. All the examples that I've given from 1 to 13, it is explicit. Explicit in the sense that you have y at one side, then function of x at the other side. But in this case now, you have both x and y, the dependent and independent variable together. So how do you find the y dx in this case? You can have this type of question. How do we find the y dx? This is what we're going to do. If we differentiate x squared, we're going to have 2x. But if we differentiate y squared, we are going to have 2y. But because y is dependent variable, we are going to add the y dx. Whenever you differentiate y, you add the y dx with it. It's equal to, if you differentiate constant, is 0. Then I can move this to the other side so that I will have 2y dy dx to be equal to minus 2x. I will divide both sides by 2y. Divide both sides by 2y. 2y will take care of 2y. 2 will cancel 2. At the end of the day, we are going to get dy dx to be equal to minus x all over y. So this example 13 is example under implicit differentiation. Differentiation in which we have the value of both the dependent and independent variables together. So that is implicit differentiation. So you can have this type of question. You should be expecting something like this. Okay? When you differentiate x, just write it out. Whenever you differentiate y, that will be 2y. It is compulsory to add y dx to it. The when you differentiate constant is 0. So just make dy dx something to formula. Then we are going to get what you are asked to find. So you can get question under this also. It's possible to have question under implicit differentiation. So it is possible. So we should prepare our mind that we can actually have question under implicit differentiation. So we should take note of that. Okay? We can also have question under logarithm, that is derivative of logarithmic function. Let's say example 14. Example 14. We can have this type of question. It is possible to have something like differentiate y is equal to log e sine x. Okay, so this is example under logarithm function. Okay, but we must know the general formula. Before we solve this, let me just tell us the general formula. If y is equal to log ex, this is a natural logarithm. Okay, and the same thing as it is called in x. Okay, when we have y to be equal to log ex, which is same thing as in x, then dy dx is automatically 1 over s. That's what the law says under logarithmic function. Please take note. Okay, so now we now go back to example 14. How do we solve that example 14? We are going to use function of a function. So how do we solve this? Just go, let's see. You have a question in this problem. You say let u to represent sine x. If u represents sine x, then of course we find u dx to be cos x. Okay, so that y will now be equal to log ue, which is the same thing as nu. When we have log ex, it is the same thing as ln x in x, because it's called natural logarithm. So when we differentiate this, dy du will be equal to what? 1 over u. That is what the law says. So at the end of the day, dy dx will be equal to dy du multiplied by du dx. So dy du is 1 over u multiplied by du dx is cos x. So we are going to have cos x all over, what is u? U is sin x. Of course, this is, tan is same thing as tangent is same thing as sin over cos. But this is the inverse, reciprocal of tan. This is reciprocal of tan, okay? What we have there is reciprocal of tan, and that will be cot. At the end of the day, the value of our dy dx will not be cot x. That's what we are going to get. So example 14 is example under derivative of logarithm functions. So natural, when you have natural logarithm, and if you don't have natural logarithm, there's a way we can do it. Okay, these are likely questions that will come out tomorrow. The question cannot exceed what we are discussing. Then let's say example 15. Example 15. Let's say example 15. That's what somebody is talking about. The person is talking about higher derivative. That is, we have been talking about dy dx. We can have more than dy dx, and we can have the square y over dx squared. That's second derivative. We can have the cube y. The person can say if y is equal to s squared plus 3s squared minus 8, find y squared. That is the second derivative, the third derivative, the fourth derivative. You can even have more than this. We have something like the cube y over the s cube. So what do you do here? This is what you do. You first find the first derivative, dy dx. If you find dy dx, that will be 4 times x. We have 4x raised power 4 minus 1, that's 3, plus 3 times 2, 6s raised power 1. The derivative of the constant is 0. So this is the first one. Then you will now go ahead and differentiate the second time, because we are talking about the square y all over the s squared. So we are going to have the square y all over the s squared. This is second derivative. So you have 3 times 4, that will be 12. 3 minus 1, 12s squared, plus 6. So this is the second derivative. Okay? So this is that order higher derivative. This is that order higher derivative. So it's the second one. Of course, you can even be asked to find the cube all over the s cube. So if you have to find the cube, but then of course they are telling you to differentiate the total. So we have the cube y all over the s cube, and that will be 2 times 12, that will be 24. 2 minus 1 x. That's what we are going to get, because this is a constant. The derivative of constant is 0. So this example under higher derivative. Okay, this example under somebody asked the question on higher derivative. It's a question under higher derivative. So these are likely questions that we can have under differentiation. Under differentiation. So we have done about 3 revision classes before. You can just go and visit. Don't go to my YouTube channel. You go and get that done. So I'll move to integration. We have not done anything on integration. We have heard about 3 classes under differentiation before. Revision 1, 2, 3. So you can go to my channel, my YouTube channel, and check it out. So let me now go to integration, which is the opposite of differentiation. Okay? What is integration? Integration is just the reverse of differentiation. Under differentiation, if you have y, if you are given y to be a function of s, we are going to find the y dx. That is derivative of that function. That will be f prime of x. Okay? But under integration, if you are given the derivative, you are not asked to find the function. So you realize that it is the opposite. Okay? Under integration, you are given the derivative, you are asked to find the function. So integration is the inverse of differentiation, is anti-differentiation. So if in this case now we have dy dx to be equal to s raised per n, okay, then how do we get y? You are given under differentiation, you are given the function, you have to find the derivative of that function. But under integration, you are given the derivative of the function, you have to find the function. Then y will now be this is a polynomial function. You add 1 to the power s raised power n plus 1 all over n plus 1. That's what you're going to get. Okay? Because you are under integration, you are given the derivative that we look for in the case of differentiation. You are now asked to find the function, then plus arbitrary constant. So whenever you integrate, it is a must to put arbitrary constant. Anytime we differentiate, it is compulsory to put arbitrary constant. It is compulsory. We just have to put arbitrary constant. It's a must. to put arbitrary constant. So please let's take note that whenever we differentiate, it is compulsory to put arbitrary constant. So please let's take note. It's a must. Let's take note. Okay? Whenever we differentiate, let's take note that is a must to put arbitrary constant. So please, we must note that. We're not going to have any problem because integration is the reverse of differentiation. So we should take note of that. So I can now go into examples. Okay? Under integration, we'll be given derivative. You'll be asked to find the function. But under differentiation, we are given the function, you are asked to find the derivative. Okay? Please take note of differentiation. You are given a function, you are asked to find the derivative, differentiate. Integration, you are given the derivative, you are asked to find the function. So they can even ask you a theoretical question. That what is integration? They put different options there. Anti-differentiation. So integration is anti-differentiation. So let's take note. And whenever we integrate, it's compulsory to put this thing. It is called arbitrary constant. It's a must to put this thing. Whenever we integrate, that is when we integrate without bounds, which is called, that one is called integration indefinite integral. It is called indefinite integral. So whenever you differentiate and you integrate, you must put arbitrary constant. So it's a must. Let's take note. Let's take note. So we can go to examples now. Let's go into examples. Let's see the likely question that we can get. Okay? Since we know the meaning of integration, we can just go. We can go into example. We can give examples so that we can know we can actually talk about the likely question that we can come across. Okay? So now let's see. The question has said evaluate. You can be asked to evaluate. Let me change this marker. You can be asked to evaluate. What do we want to evaluate? You can be asked to evaluate x raised power 3 over 2 dx. That's another thing. Whenever you have this integral sign, there must be derivative of that function behind it. If this is x, the x must be there. If this is y, the y must be there. So let's look at example 15. We have to integrate x raised power 3 over 2 dx. What do we do here? No, this is the derivative. We want to find that function. We are going to say x raised power 3 over 2. You add plus 1 to it, this power. Whatever you have at the power, we are going to write it as the denominator 3 over 2 plus 1, then plus arbitrary constant. Okay? When you add 3 plus 2, that will be 5 over 2. 3 plus 2 is plus 1, that's 5 over 2. We are going to have x raised power 5 over 2 all over 5 over 2 plus arbitrary constant. Of course, if you have 5 over 2 at the denominator, you can rewrite this as 2 can come up so that you have 2 x raised power 5 over 2 all over 5 plus arbitrary constant. That will be the answer. Okay? That will be the answer. But in this case now, look at this example 15 very well. I want to establish a fact. This example 15 is an example of indefinite integral. Indefinite in the sense that it has no boundary, no bound. It is open-ended at both the lower and the upper bound. No restriction. Okay? So whenever you integrate indefinite integral, you must put arbitrary constant. It's a must to put arbitrary constant. So please let's take note. Whenever you integrate indefinite integral without bounds, that is open-ended, is a must to put arbitrary constant. So please let's take note. Let's take note. So you can have this type of problem. Evaluate, you can be asked to evaluate x raised power 4 dx. This same thing as x raised power 4. If you want to integrate for that will be 4 plus 1 all over 4 plus 1. Under integration of trigonometric function, this is what we are going to do. Plus arbitrary constant. Okay? And you are going to have x raised power 5 over 5 plus, and that's the answer. So when you integrate indefinite integral, is a must to put arbitrary constant. Is a must to put arbitrary constant. Then let's see another example. For example, 16 or 17. What if you now have integration of this form? If you have something of this form, integral 2x plus 5, or say minus 5, raised to power 4 or raised to power 3 dx. You can be given this type of problem. What are you going to do? How do you approach this type of problem? It's also simple. In this case now, we are going to use let statement. It's very simple. We are going to represent what you have inside that bracket, 2x minus 5, is called core. It's called core. We call this one core. Okay? We are going to represent that core with another function. Say maybe u. We represent it with another function. Say u. Okay? After this, I will stop the class and probably I will refix the lecture. We can come up maybe around 9 or 10. I'll send notification so that people should rest. At least we have spent about 4 hours, about 40 minutes. So after this example, I will stop. Then we'll come back later. In this case now, we have integral 2x minus 5 cube dx. So here we say let u is equal to 2x minus 5, so that the u dx can be equal to 2. That's what you get. At the end of the day, you have integral u cube. Then what if the u dx? Look at before that. If the u dx is equal to 2, let's make the x the formula. The x will now be equal to what? The u all over 2. Okay? So I will now come to this problem. The problem is now integral u cube, because we've decided to represent u as the core 1 over 2. So if I integrate u cube, that will be u 3 plus 1. That will be u raised to power 4. Then all over 4 plus arbitrary constant. At the end of the day, I'm going to have 1 all over 2 times 4. That's 8. U raised to power plus arbitrary constant. What is u? U is 2x plus 5. So I'm going to have ux 2x minus 5 raised to power 4 all over 8 plus arbitrary constant. That's what I'm going to get. Okay? That is what I'm going to get. So we should take note that is what I'm going to get. So let's take note. So I will love to stop at this point. Digest what we have discussed. Probably later in the day by say 9:30. 9:30. I will send notification. You can actually come back. So digest what we have done before. But what you have done now, then we come back later. Just go through what we have discussed. All right. Let's stop the class now. I want you to digest what you have done now. Then by 9 o'clock, I will come back. Just go through this so that we can concentrate on go through this. We have about 3 videos also. Go through this by 9 o'clock. Then we'll come back. Or probably if you want us to do it very early in the morning so that it will be fresh in your memory. All right. Thank you.